Hi, everybody. Welcome back to Dave's Math channel. I'm your host, David Tare, and this is my continuing feature on the Math Lovers book, three-volume series I wrote from 2019 to 2022 that's available on Amazon.com in both Kindle and paperback. In case you're interested, you can either search for my name, David Tare, or the Math Lovers book, and you can buy any one of these volumes or any combination thereof. Anyway, that's a pitch for my book. I haven't done that in a while. But I'm going through this book on this channel. You don't have to pay for watching my videos on this channel. And I'm now on chapter 5 of volume 1, which is on set theory. Just started this a couple days ago. And today I'm going to talk about Venn diagrams. And these are very useful diagrams for, pictures for illustrating sets and the relationships to each other. Then by an English mathematician named John Venn in the late 19th century. So anyway, let's begin. So I'm gonna just give you some examples of Venn diagrams because, like they say, a picture's worth 1,000 words. So imagine we have these four sets here. These are just four sets of numbers. Our universe is the numbers 1 through 10, and then we have three other sets. A is a set 1, 4, 5, 7. B is 2, 4, 5, 8, and C is the numbers 1 through 8. So let's see how we would illustrate these three sets and the universe in a Venn diagram. Well, here's how you would do it. So you'll usually draw the universe as a big rectangle. It's kind of the set. Remember, yesterday I said the universe or the universal set is the set that contains everything we're interested in. So you'll never go outside the universe when you're discussing a particular collection of sets you're interested in. So our universe, as you can see, consists of all the numbers 1 through 10. And I think you can also see that 9 and 10 do not lie in any of these three sets, A, B, or C. They're kind of outliers. And then C is the biggest of these sets. That's the set with the numbers 1 through 8. So that has every number in the universe except 9 and 10. And then you can see that A and B are both subsets of C. That's not so obvious when you just look at the definitions of these sets, but when you actually draw this Venn diagram, you can just at a glance see the relationships between these sets. So now, once we've drawn this Venn diagram, notice that A has the elements 1, 4, 5, 7, like I said, and B has elements 2, 4, 5, 8. So you can see right at a glance that A and B are both subsets of C. That wasn't so obvious looking at this. But you can also see that um, A and B are not neither of them is a subset of each other, but they intersect, and their intersection is this set 4 comma 5. That's A intersect B. And you could also, if you want, you could get the union of A and B. That's just all the elements common of both A and B. You can just read those off from the elements inside. That would be 1, 2, 4, 5, 7, 8. So I think you get an idea how useful this is. Or if you wanted to do, say C exclude A union B, then you can see that's this set 3 comma 6. So you kind of see at a glance the relationships between these sets. So it's very useful, and like many people say, a picture is worth 1,000 words, and I think Venn diagrams are a good case in point of that. So, and let's just do another example. How about this is kind of a fun example I came up with. Say the universe is the set of all 7 continents on Earth. And just in case you guys don't know, the continents are Africa, Antarctica, Asia, Australia, Europe, North America, and South America. That's in alphabetical order. And, it turns out that you can kind of group the continents into three groups that are all each connected to each other. It turns out that, for instance, North America and South America are connected, or at least they used to be before the Panama Canal was built. But I think you could still say they're connected because the Panama Canal was man-made. They were connected by nature anyway. I'm talking about today, and of course, there's things like continental drift. This wasn't always the case. As a matter of fact, all 7 continents were once connected into a big thing called Pangaea about 200 million years ago, and then they all kind of got separated from each other. Another interesting fact, I'm really digressing here, but India, I don't know how many guys realize this, but India used to be a continent, used to be a separate continent. It came off of Antarctica, but then it drifted up north through the Indian Ocean and ended up bumping into Asia, and that's what created the Himalayas, which are the tallest mountains in the world. So continents are moving, but they move on a very, very long geological time scale of millions of years. So I think, for all of us and our children, our grandchildren, we're basically going to be drawing the same maps of the world. Anyway, enough of a digression about all that. Then what else is connected? It turns out that, what do I have here? I have Africa, Asia, and Europe. Those are all connected. It turns out they're all kind of connected right around, right around, I guess, around where Israel is, Sinai Peninsula. And finally, Australia and Antarctica. Those aren't connected, it turns out. I wanted to show you a Venn diagram. So this looks a little like a very simplified world map, I feel like, but no worse than the TO maps from the Middle Ages. But it shows the relationship between these continents. So you can see at a glance what it looks like. You got A consisting of North and South America, kind of in their respective locations roughly. And then you got B, which consists of Europe, Asia, and Africa. And then you got C, which consists of Australia and Antarctica. And you can see that the way I define these sets, they're all disjoint from each other. This is called disjoint. So there's no intersection. There's no intersection between any of these three sets. That's what we call disjoint sets. And I think I just want to say one more thing before I get off. I hope I don't get in trouble for this because, I shouldn't make politically charged topics on this channel. But I don't know if you guys remember a couple of months ago, Trump was talking about changing the name of Greenland to red, white, and blue land, which I thought was really horrible. First of all, he wanted to take Greenland from Denmark. I don't think the Danes even really care about that. It was kind of a joke. I heard that Vance went to Greenland and they didn't even have any place to accommodate him there. So it wasn't a very comfortable trip for him. So the joke was on him, I guess. But I do math problems on I'm on Facebook and I do these daily math problems. And shortly after this news came out about red, white, and blue land, I was kind of sick about it. So I made a problem on that in this group that I'm in, where I said I gave the same relationships that I just talked about between these continents, but Australia and Antarctica were separate. So I asked people. I said, suppose we wanted to color each continent either red, white, or blue in such a way that no two connecting continents have the same color. And then I asked people how many different ways you could do that. You might want to think about this problem yourself. Maybe I'll give you a few seconds to think about it. You can pause the video if you don't want me to tell you the answer. So I'll give you a few seconds to think about it, or you can pause it however long you want. But now I'll just tell you the answer. It turns out it's 324. There's 324 ways you could color all seven continents red, white, and blue in such a way that no two connecting continents have the same color. So I don't know if Trump would be interested in that or not. He probably wouldn't understand what I just said anyway. Hopefully you guys do though. So anyway, that completes my video for today. Thank you for watching. Long live math, and I'll see you guys next time. Bye.